In this unit, we are going to see how we can submit a SWAT model for auto-calibration in SWATShare. In the previous unit, we looked at how to upload a SWAT model in SWATShare. So before we proceed, let's make sure that the model that we uploaded exists. So you can check that by going to My Models, and you should see your model here. So in my case, I have many. If you used SWATShare for the first time, you will see only your model. So in order to submit a simulation, we have to use the Simulation tab. And again, in my case, you see many other models here. In your case, if you have never run auto calibration or any type of simulation, you will not see anything here. So what we are going to do is we are going to click on Run New Simulation, and when you click that button, it will show all the models that you have in your profile that you can use for simulation. So in my case, I have many. In your case, you may have only your Cedar Creek model. So click that model, and on the top you will see the steps that we are going to follow to finish this process. So there are 6 steps. So we select the model that we want to submit for auto calibration, say next. And in the next step, we are going to set some basic properties, and we are going to assign a name. So we are going to say Cedar, and you can pick whatever name you want. So in my case, I'm going to say Cedar Creek Auto Calibration Test. I'm again not using any space or special characters. When we submitted the model, we said that we want to submit this for auto calibration, so that's why this is already selected. If not, you can pick which one you want. So there are different colors. Normal simulation is green, sensitivity analysis is orange, auto calibration is red. New simulation period and step. So we have run this simulation in QSWAT, and the model files already exist all that information. So it is asking us, do you want to change anything? If you want to change anything, you can select yes and specify. If you do not want to change anything, you can use whatever you have in your existing model. So in my case, I'm going to say no. I will just use my daily time step, and the simulation period was 2004 to 2010. And then we go to next. In the next step, we are going to specify properties related to the auto calibration routine. So this auto calibration or optimization routine is based on genetic algorithm. So there are some default parameters here. So in our case, the default is 50 and 100, and you can see that it is recommended to try with small numbers first. And the reason for that is you specify small numbers of generation and iteration. So in this case, let's say 2 and 6 as the guidance says. The reason for that is to make sure that everything runs and we are able to get the results. And if everything runs, and then you can change those parameters and play around with the optimization algorithm. When you specify smaller values for generation and iteration, it will finish faster. Objective function, we can pick any objective function we want. So let's pick the Nash Sutcliffe efficiency coefficient, and we are simulating this for hydrology. So we want to calibrate against observed stream flow data. You can see that there are more options here if you want to pick other variables. So right now we are only picking stream flow, and since we are calibrating our model against observed stream flow data, we need observed stream flow data. So we can drag and drop our observation file or browse. So the observation file will include daily observed stream flow data for the same period that we used for simulation, which is from 2004 to 2010. and there is a handout on the specific format of that observed file, which we will not discuss here, so you can look at the handout. So let's browse. So in my case it is in class QSWAT and Cedar SWAT, and you can see observed read stream flow. Say open, and the upload is complete. So let's go to the next step. In this step we are going to specify the parameters that we want to calibrate. So let's go ahead and add these parameters. So we know that the most sensitive is curve number, so we will pick that first. So curve number. Change type, so this is going to be percentage change. Unless you specify specific subbasins and HRUs, it will do this for all the subbasins. So curve number is 1. Let's pick the next one, and we will just use the default range that is provided to us, alpha BF. This is the channel hydraulic conductivity. So we can pick some groundwater related parameters, groundwater delay. And there is a handout that will tell you what parameter you can pick. And so alpha BF, let's pick IPCO from HRU, ISCO. So we'll pick 10 and 12, and then we'll go to the next step. And as I mentioned, the details about these parameters and the range and everything that is provided to you in the handout. So the goal here is to just show you how to do this. So let's see. Yeah, surface lag, that is another parameter. So I think we have enough parameters here. As I mentioned earlier, unless we specify specific subbasins or HRUs, this will be performed on all subbasins and HRUs. And to add a parameter, we use this button. So once we specify these parameters and the range, and the goal here is to just perform initial auto calibration and see what we get. And then once you are happy with what you have gotten, you can stop. If you are not happy, then you can play around with all the parameters related to the model and the parameters related to the auto calibration routine. Say next. Contact information. So what happens here is when you submit your simulation for auto calibration, this is run on distributed computing resources, in this case exceed computational resources. So what will happen is this job is submitted to a cluster, and then if the cluster is free, your auto calibration will run immediately. If not, it stands there in a queue and it will take some time, and once the simulation is complete you will get an email. So we will go ahead and provide our email. I will provide my email, but make sure you use your email address. Say next. And then finally you have to review and make sure everything looks good. So all the parameters that we have specified, all the parameters related to the calibration. And one thing you want to remember is the calibration will be done and then you have to download the data, otherwise it will be deleted. So since this is all stored on the internet, there are limitations on how many days you can keep your data on MyGeoHub, at least for the calibration part. So just make sure after you are happy with your calibration, you download your model. So once we are happy with this, we say submit, and then in the simulation tab you will see your model name here that you just submitted. So the simulation name we gave, this is the model name, auto calibration, and you will see the status is pending, so it is in the queue. If everything runs fine, you will get an email that your auto calibration is finished and the status will be changed to done. So in this case it is pending, so let's stop here and we'll come back once the auto calibration is complete to see the results. So this is it for this unit. In the next unit, we will look at the results of auto calibration and see what we have got.